Lesson 9.3, Multiplying and Dividing Monomials. I just want to mention one thing about the word monomial. And mono means one. That means one term. We've already talked about this earlier in the year. So it could be a plain number, it can be a variable, or it can be a product of those. So for a monomial, it could be the number 5, it could be x, or it could be 2a squared b or something like that. Anything that doesn't have a plus or minus in it. For example, if you had x plus 2, that is not a monomial. So I just wanted to get that out there. One thing we're going to talk about with multiplying and dividing, the bases must be the same to add or subtract exponents. If the bases are not the same, work the problem out. So if you're doing a multiplication and the bases aren't the same, well then you should multiply. And same thing with division. So let's start off with multiplying monomials. When you multiply them and they have the same base, you add the exponents. Do not multiply the base, it stays the same. So what we're looking at here would be this: 3 to the 4th power times 3 to the 2nd power. The 3, the base stays the same, but you add 4 plus 2 and you would get 3 to the 6th power. Okay, y to the 10th times y to the 4th. You would again have y and add 10 plus 4, so y to the 14th. Next, now there we go with parentheses and a negative again. The parentheses again must remain there. Negative x to the 3rd times negative x to the 5th would be negative x to the 8th. This one, 7 to the 8th times 7. Well, there's no number above that second 7, but if it's there, it has to have a number. So the number would be 1. So therefore you would have 7 to the 8 plus 1, or 7 to the 9th. Now let's get to some where everything isn't the same. 3p to the 4th times negative 2p to the 3rd. Well, the 3 and the negative 2 definitely are not the same. So we're going to go ahead and do that operation just like it says. You take 3 times negative 2, which would be negative 6. Then you look at the p's. The p's are the same base. I have 4 in the first term and 3 in the second, so you would say negative 6p to the 7th. And since we went ahead and multiplied that out, I don't have to put that in parentheses. The negative 6 does not have to be in parentheses after you've multiplied it out. Okay, finally, negative 4f times negative 5f. Again, the negative 4 and negative 5 are not the same, so negative times negative is positive. 4 times 5 is 20. Then I have two f's. Remember, f to the 1st, f to the 1st, you would say f to the 2nd. So that would be positive 20 f to the 2nd. So multiplying, if they have the same base, then you add the exponents. If they don't have the same base, you go ahead and multiply those things out. Now let's switch to division. Division, you're going to okay, so for division, when dividing, again, it has to be the same base, and you are now going to subtract the exponents. So multiply, you add. Dividing, you subtract, but it's got to be the same base. Do not divide the bases. It stays the same. Here's what we mean. 6 to the 7th power and 6 to the 2nd power. So that would result in a 6. The base does not change. And 7 minus 2 would be 5. 6 to the 5th power. 4 to the 11th over 4 to the 4th. So you leave the 4, and 11 minus 4 is 7. 4 to the 7th power. And finally, negative x to the 12th. In negative x, well, if there's nothing written there, we know it's a 1. We've got to keep negative x in parentheses, and 12 minus 1 would be 11. There is one more that I want to show you. If I had a to the 5th over a to the 5th, then that would be an a, and 5 minus 5 is 0. And what we learned yesterday was anything to the 0 power is 1. But if you look at this, it's just like any other fraction. If you have the same number on top and bottom, it would reduce to 1.